Okay, this is the second video on amortization tables. And in this case, we're going to look at making payments. So we want to set up our table the same way. So I'm going to start my first period, and then the next line will be the previous value plus 1, so that I can copy down. My scenario that I'm looking at is that I want to take out a loan for $20,000 to purchase the car. So my starting balance for my loan is $20,000. I am making I'm paying interest on the loan for 6% compounded monthly. So that's going to be 6% divided by 12 for my rate per period. And I can represent that as a percent. My interest earned is going to be my balance times my rate. And again, this is essentially a simple interest calculation. And then I'm going to be able, according to my budget, make payments of $350 per month. And so my ending balance, in this case, because it's a loan, the interest is increasing the balance in my account, but the payment is decreasing the balance in my account because it's a loan. So my starting balance will then add in the interest and then subtract off the payment. And so you can see from this calculation that essentially, because of the interest that I'm paying, only $250 of my payment is going toward reducing the amount of money that I owe, because the first $100 has to cover the interest. Now, if this was a savings account where I started with some balance and I was adding payments to the account, the interest and the payments would go in the same direction. It would both be adding to the balance, but in this case, they're going in opposite directions. Obviously, your balance is not going to decrease if you don't make a payment that's at least as big as the interest. For those of us that have student loans, we know what this is like when you don't make payments that are big enough to cover the interest. The balance just keeps going up. And so in the end, I have reduced the amount that I owe by $250 in this case. Now, in the next line, the next period, the value from the end of the first period comes down. The interest rate remains the same. And the interest, it follows the same formula. So it's the starting balance times the interest rate. So I can copy this formula. The payment is going to remain the same for our initial calculation. And one of the reasons that I put this equal to the previous value before I copy it is because sometimes Excel tries to be helpful, and then it will add $1 to every payment when you copy it down. So this way, if I set this equal to the previous value, then it will stay $350 instead of slowly incrementing to 350, 351, 352, and so forth. And then finally, the end is the same formula. It is the starting amount plus the interest minus the payment. And notice, since my interest went down a little bit more of my money is going to go, of my payment is going to go toward reducing the balance. And once I have the second row calculated with all of the references to the previous line, and now I can copy the formula down, and I'll just copy it down a couple of lines so we can see what happens. So notice that the interest keeps reducing because the amount in my account is going down. And what I want to know is, how long does it take to pay this off? Well, now 18 payments is 1.5 years, and I'm definitely not there yet. Let's see where we're at 3 years. No, one more. I'm about halfway there, but not quite there. Now, as the interest decreases, the amount of the payments, the amount from the payments that will go toward the balance will get larger. And so even though it took me 36 months to get to the halfway point, it probably won't take me 36 more months to get to the end. So I'm going to try 60 months, which is 5 years. Very close. Let's try a few more. Okay, so notice what happened right here. This line, I'll highlight it. This balance right here, the parentheses around it actually is the sign in Excel that the balance has gone negative. And so that means that 69 months is how long it will take me to pay this off. 68 months of full $350 payments. And then the last $350 payment, I'll actually end up with an excess of $187.89 that the company will have to pay back to me. So essentially, the last amount that I owe will actually just be the balance at the beginning of this cycle plus the interest. And so the amount that I will owe on this last payment to pay off the loan will be $162.11. But at $350 a month, this will only take me 69 payments. So if I took out a loan for a 6-year term, I would, at $350 a month, I would pay this off sooner. Now, one of the nice things about amortization tables is that I can play around with, well, what happens if I increase or decrease my payment? Because I have all of this stuff calculated, I can just change this value at the top. I paid it off in a little bit less than 6 years. So maybe I could decrease my payments slightly. And that will take a little bit longer. But I'm still hitting negative values before I get to the end. So maybe 340. $335 maybe. It's just too wide for the column. That's pretty close. There we go. So at about 336, not quite. Actually, I guess 335 was good. Because I didn't have, there we go. So 335 or give or take some change is the payment that you would have to make as a minimum in order to get to pay this off after approximately 72 months. And we could use the payment formula in order to calculate the exact value that would get us as close to zero on this last payment as possible. And we could sit here and play around with it. That would be fine. But we could also say, well, maybe I find out after I've agreed to $350 a month, maybe I can go up to $450 per month. Maybe I can pay it off faster. I'm going to pay it off in 51 months if I do that. So you can calculate, as we did in previous videos, what the interest is, what the total amount is that you paid at the end of the period, at the end of the cycle, by the time you've paid off the loan, and you can figure out how much interest you've saved from these different scenarios by paying it off, paying a little bit more, or paying a little bit less. You can certainly do that with the payment formulas, but using an amortization table, you could figure, well, I can only afford $350 right now, but after a year of making payments, I'm going to up that to $400. And then after another year of making payments, I'm figuring I'm getting a raise, right? So I can up that to $450. And so these kinds of adjustments are not things that you can do easily. You have to calculate each one separately. If you want to make adjustments to the size of your payments, how long this is going to take to pay off, once you've built the table, you can make these adjustments very easily in your calculations, and it will tell you right away exactly how much more time that's going to save you when you make these adjustments. And you can just do it right in the table. And this is, again, this is not something that you can do easily in the formulas. Every time you made a change, you would have to figure out what the present value is, figure out, do all these recalculations. But with the amortization table, it allows you to make these adjustments on the fly and then immediately see how the balance is affected.